Before we leave Newton's method, I think I owe you one explanation. When we considered the equation fx is 0 and we replace this with t1x is 0, I told you that t1 can be written as function value at x0 plus the derivative at x0 times x minus x0 for the one-dimensional case, and for the vector case, this is f derivative at f arrow at x0 arrow plus j, the Jacobi matrix of partial derivatives, times x minus x0. I think this term is not so very obvious for people that see that for the first time in their life. So let me explain this. If we have, say, two functions, then f1 and f2, each of them can be approximated by t1, namely f1 at the point x0, y0, this is at the point x1, plus partial derivative of f with respect to x times x minus x0 plus partial derivative of f with respect to y, f1, y minus y0. And the second function, f2, at the point, approximated. And this is f2 at the old point x0, y0 plus. And now we have the f2, partial derivative with respect to x, times x minus x0, plus partial derivative f2 with respect to y, at the point x0, y0 times y minus y0. So this is the constant term, and these four contributions can be written exactly in the form of a matrix. When we introduce the Jacobi matrix as the partial derivative of f1 with respect to x, partial derivative of f1 with respect to y, and partial derivative of f2 with respect to x and f2 y. Then if we multiply this by the difference x minus x0, which is actually a column, which is a column vector x minus x0, y minus y0. This is with arrows, this is without arrows. Then when we multiply by this vector, then when we perform this multiplication, matrix times the column vector, we get exactly this term. You see, this times this, which is here, plus this times this, which is here. This is the first row, this is the first component of the resulting vector. And this times this, which is this contribution, plus this times this, which is this term. So this is good to write down and good to consider what we mean by matrix times the vector of the displacement, and this is the linear contribution to T1.